Okay, so in this video, we're going to give you a kind of high-level overview of what's to come in section 3.2, which is the section that deals with how to add and subtract vectors using the graphical method. So let's take a look at that on the whiteboard. So if I just, once again, we're in 2 dimensions. So if I go ahead and draw my axes again here. So I've got my y-axis and my x-axis. And let us suppose that I have a vector, we'll call it A. Okay, and let us also suppose that I have another vector, and we can call it B. That goes like that. And let's suppose that we are interested in knowing what is the sum of A and B. So remember, vectors are kind of similar to scalars in the sense that when you add 2 vectors together, you get another vector, okay? Just like how if you add 2 numbers, 2 scalars together, you get another scalar. And so what I'm going to show you now is the graphical method that you would use to add vectors. So as I've said in a previous lecture, when you want to add 2 vectors together, what you want to do is you want to add them by taking them head to tail. So I think I also may have mentioned that vectors were portable. You can pick them up and move them around as you see fit. So I'm going to pick up vector B and I'm going to move it so that its tail is in contact with the head of vector A, like that. Okay, and then to find the sum of A and B, what you do is you begin at the tail of A and you end at the head of B, and so you get a vector that we're going to call C, and you can represent it like that. Now, if you were asked, okay, if you were told to add A to B to get C, and then you were asked, well, yeah, but can you describe to me the vector C without drawing a picture of it? How would you do it? Well, then you would say that C is equal to a certain number, right? It has a magnitude. So we say C meters, right? So the unit of the magnitude is meters because X is in meters and Y is in meters in this example. And we would say, so that gives you the magnitude, and we'd say, well, what direction is it? So it looks like C is pretty much due north. So you would say, you can say due north, right? So this is the north direction, and that's east, that's west, and that's south. You could also say something like C meters, 0 degrees west of north. Okay, if you wanted to give an angle. In this case, it's 0 or close to 0, but that's sort of how you describe it. Okay, so that's how you add vectors. But what if you wanted to subtract them? What would you do? Well, here, let's see. What I can do is I will erase these vectors that I have here, and I'm going to go ahead and redraw vector B. So let's say there's vector B. And so let's suppose I want to find out, how do I subtract B from A? Well, in this case, I'm not doing an addition, I'm doing a subtraction. And so in order to subtract one vector from another, what you want to do is you want to take the vector that you're subtracting and apply the minus sign to it. In other words, we'd make it a negative of itself, and then we'd add A to the negative of B. Okay? So when you multiply a vector by -1, all you're doing is just keeping it the same, but you're just flipping its direction exactly 180 degrees. So I would go ahead and I would draw minus B. So that's going to be exactly parallel to B. It's going to be exactly the same length, but it's going to be pointing in precisely the opposite direction. So this is what minus B looks like. And so once I have minus B, I can add it to A, again by going head to tail. So let me go ahead and see if I can select this. So I'm going to pick this up and move it on over to here. And so now I have A and B going head to tail, or A and minus B, excuse me, going head to tail. And so now my sum, just as before, will originate at the tail of A and terminate at the head of minus B. And so we'll call this vector D. D is in delta. And so now this time, if we were to sort of see how many, what the direction is of D, we would say that D is D meters theta degrees west of north. Okay. And how do you actually get, again, if we're using the graphical method, how would you get this magnitude and this direction angle? Why, you'd have to get out a ruler and measure the length of this vector, and then that would be your magnitude, and you'd get out a protractor and you'd actually measure this angle, and that would be your direction angle. And so hopefully through all this, you've seen not only can you add and subtract vectors, you can also multiply them by a scalar. So what we sort of did here in going from B to minus B is we took the vector B and we multiplied it by -1. So, and you can do this, it doesn't have to be -1. You can take any scalar and multiply a vector by it, and you get another vector. When you multiply a scalar and a vector, you get another vector. And all that happens is that the magnitude of the vector gets adjusted by whatever factor the scalar is. So for example, if I wanted to know what was 2 times B, well, why then I would take this scalar 2 and I'd multiply b by it. And what that does is it produces a vector that's exactly in the same direction, but it's going to be exactly twice as long. So this right here is known as 2b. Okay, or if this was a half, then it would be same direction, but half as long, and so on. So hopefully now you've seen how to add, how to subtract, and how to multiply by a scalar vectors in 2 dimensions.